Hydro is the Greek word for water, and so hydroelectric power is electricity that's generated with water. And this is a classic case of mechanical energy being converted to electrical energy. In this case, it's the moving water that spins the wheel that turns the turbine, that turns the generator. This is a really ancient way of generating power. And by power, I also mean mechanical power. In the centuries and millennia before electricity was developed, we used water wheels to run all sorts of equipment. There are still some working mills back on the East Coast that are wonderful examples of working water mills. There are some beautiful examples in Europe, more than in the US. And when the Industrial Revolution came along, our friend Nikola Tesla discovered alternating current. And with alternating current, it was possible to place a generator far away from where the power was needed. So, for example, we could have Bonneville Dam up on the Columbia River sending electricity down to Southern California. This is just a related technology. It's called pumped storage, and here you essentially create a dam up in the air and you pump water up there. This is a pumped storage facility in Pennsylvania. Here's another one. I forget where this is. And then here's one in England. Let me back up here. So how they work is the water running through the dam generates some electricity, and that electricity can run a pump which pumps water back up into the reservoir for storage. So it's a form of potential energy. It's potential kinetic energy being stored up there. This is not a perpetual motion machine, by the way. You don't get something for nothing. But it is kind of like a battery in a way, a giant battery. Here's how a hydroelectric plant works. So there's a dam. Usually it's made of concrete. Sometimes it's made of earth and rocks. And it's built across a river. The river water can't get through the dam, so it begins to back up and it gets deeper and deeper. And that creates pressure that helps push the water through the gates. The operator opens the gate. Water flows through into this giant tube called a penstock. It flows onto a turbine. This is like a snail shell with a decreasing radius, so it goes faster and faster as it goes in here. That's connected to a generator, and you know about generators. The generator spins in a circle with arms going through a magnetic field, creates alternating current, and off we go. Hydroelectric power is classified as renewable energy, and in fact, when you look at reports from the IEA or the EIA, reports of quantities of renewable energy, when you study their graphs, you'll notice that in almost all cases, the majority of the renewable energy being reported is from hydropower. Hydroelectric power, you can say hydropower for short. And people like it because water running through a turbine appears not to produce any greenhouse gases, so that's great. Here's the problem, and you know there are always trade-offs with any method, and here's the trade-off with hydroelectric dams. The river builds up behind the dam, and all that particle matter that would have gotten carried by the river down to the ocean can't get through the dam now, so it begins to build up behind the dam. That silt carries with it plant material, and as it builds up and gets deeper and deeper, that plant material begins to decompose, and how it decomposes is Our friends, the old anaerobic bacteria, are eating that plant material. And what do those guys give off? Those guys give off methane. So as this silt laden with plants builds up behind the dam, anaerobic bacteria decompose it and they give off methane, and apparently a lot of it. Some researchers analyzing the quantities believe that hydroelectric dams are responsible for more carbon dioxide and methane emissions than coal-fired power plants. That's not 100% conclusive yet. There's some scientific uncertainty, and the researchers are still working on this. Nevertheless, we know that dams are responsible for a lot of greenhouse gas emissions. There's no question about that. They are also responsible for damage to living systems on which we all depend. So that soil that gets trapped behind the dam, that is soil that would have been carried down through the valleys and to the oceans. The rivers cannot do the work of rivers, and the work of a river is to, well, of a river system, is to erode the rocks in the mountains upstream, starting with little tiny streams and gradually getting bigger and bigger. And up in the steep mountains, these streams pull off big rocks. They get carried down the steep streams, and as we go downstream, the streams come together and get bigger. The big rocks drop out, smaller particles keep getting carried, and as we go further downstream, the river gets wider and wider. Particles drop out, and the particles being carried get smaller and smaller until we finally get to the river delta out at the ocean, where this rich sediment drops out. That's the work of a river, and all of that is now shut off because of these dams. And because of the damage to these stream systems and because of this particulate matter, fish and other folks who live in the rivers can't survive, and so their populations are declining. Oh, and I should mention also, as you are probably aware, anadromous fish like salmon live part of their life in the river and part of their life in the ocean. And there's a big problem with them trying to get back from the ocean back up to their spawning grounds and being blocked by dams. So some dams put in fish ladders and trucks and stuff, and it helps a little, but it doesn't solve the problem. So the rivers cannot do the work of rivers, the ecosystems cannot function the way they should, and methane is given off from the sediments trapped behind the river, behind the dam. There is also damage to human culture. Right here in Oregon, on the Columbia River, here's the Bonneville Dam. You're probably familiar with the Bonneville Dam. That's where we get most of our electricity down here in Lane County. And until 1957, this is what the rapids there at Bonneville Dam looked like. This was called Celilo Falls. And I'm actually old enough to remember watching these people in their great fishery in the fall, standing out on their platforms. It was really dangerous, and they parents passed it down to their children how to do this. Celilo Falls was at a place where two kinds of two language-speaking groups met. The Chinookan Indians were along the Columbia River to the west, and the Sahaptian-speaking tribes were from the Celilo Falls to the east. The Chinookans, and especially the Chinooks themselves, were a merchant tribe. They were pretty wealthy. They had quite a developed civilization, and they ran a great marketplace on the Columbia River, and every fall these massive numbers of people from all over the Northwest, and we now know from the Midwest, would come and meet at this great marketplace to trade. And the Chinooks brought salmon. They made great drying racks and dried the salmon so that it could be transported and kept. The Calapooians in the Willamette Valley brought dried camas root and dried hazelnuts and dried berries pounded into cakes that they would trade. The people who lived in Central Oregon near Bend had a manufacturing site on Newberry Crater, and they would bring obsidian blanks that were ready to be made into spear points and arrows. Others brought various kinds of furs. It was enormous, and it was a great way to get goods that you needed and to exchange them. Well, in 1957, that all ended. And the dam was built. Celilo Falls was buried, submerged in water. The people who used to live there were moved to a little trailer parky thing someplace else along the Columbia River, but of course their culture was lost and it was never the same. Culture was lost on the Nile River as well. You know about the ancient Egyptians with their great culture, the great sculptures and the great pyramids and so forth. Their culture was possible because of the work of the Nile River, which meandered across this vast plain and, doing the work of rivers, dropped rich silt. And this rich silt made a lot of farming possible, and it made the Egyptian culture possible. Well, in 1960, the Aswan Dam was built, and it dammed up the Nile River. And so great archaeological sites were submerged in the river that backed up, and we can't get to them anymore. And the Nile is no longer able to bring this rich silt downstream, and so ironically, now, because the farmers here don't have that rich silt, Egypt is now one of the largest users of synthetic nitrogen fertilizer in the world. So there are trade-offs.